good day, students. In today's class, we want to study degree of differential equation. In the last class, I explained order of a differential equation as the highest order derivative in a given differential equation. That is, if you have dy dx minus 2x is equal to 0. What you need to do here to find the order is that how many times was this one differentiated? You can see that it was differentiated once. So now you can say the order is equal to 1. So if you also have the squared y dx squared plus, let's say, 5 dy dx all squared is equal to 0. The power here doesn't concern you for order. So what concerns you is the highest derivative. How many times was it differentiated? So this one was differentiated twice. Then you look here, the other one was differentiated just once. So you pick the one that is greater. So that means the order of this differential equation is equal to 2, and so on and so forth like that. Now, in today's class, the degree of a differential equation can be defined as the exponent. What do you understand by exponent? Exponent is the power. The exponent of the highest derivative in a given differential equation. Yes, that is the highest derivative. What is that? That is your order of a differential equation. In a given differential equation, when the derivative is made free from radicals or fractions. What do I mean by that? That is, everything has to be in polynomial form. Polynomial form, that is the derivative. The derivative has to be in polynomial form. So, and you remember our polynomial, that is, we have f of x to be equal to a naught x raised power n plus a subscript 1 x raised power n minus 1 plus a subscript 2 x raised power n minus 2, and so on till we get to a raised power subscript n, and so on like that. So what we are saying here is that in the power of this x, so this x will now be our derivative, the derivative. So all these ones, the power can be natural number but cannot be radicals, and it cannot be fractions. So the power can be any natural numbers but cannot be what? Radicals or fractions. So let me give you an example like that. So for examples, we have number 1, d squared y dx squared plus dy dx is equal to 0. So the first thing is that you have to determine the order, the highest derivative. Which was the highest here? The order of this one is what? 2. The order is what? 2, because this is the highest derivative. Okay, now, so what is its power? The power of that one that has the highest derivative, that is what you need, its exponent. So the exponent of this one is just 1. Is what? 1. So now we can now say that the degree is equal to 1. So the order is 2, degree is 1. So let's go to example 2. For number 2, you can see that the order of this one is what? 1. So the order is for this. Order is equal to what? 1. And the degree, that is the exponent, is what? 2. Degree is equal to 2. So you are done with that one. So example 3. Y is equal to x multiplied by dy dx plus root of 1 plus the y dx all squared. Okay, you can see that this one, the derivative here as what was on is under radical. So we cannot determine the degree from here. Does that mean that it doesn't have degree? No, it has degree. But you have to find a way of eliminate this radical. You have to eliminate this radical. So what do we do? So we can do it this way. Let's come here. Number 3, y equals x, dy dx, then plus root of 1 plus dy dx all squared. So let's x multiplied by dy come and meet y. So we have y minus x dy dx equals 1 plus dy dx all squared. So the next thing is to take square both sides. Square both sides. Squaring both sides gives y minus x dy dx all squared equals 1 plus dy dx squared. So you can see. So if you like to simplify this one. So if you simplify this one, we have what? Y squared minus 2xy dy dx, then plus x squared dy dx squared equals 1 plus dy dx all squared. So here we have dy dx here, we have dy dx here, we have dy dx here. So the order of this differential equation is what? 1. So the order is 1. The order is equal to 1. And the degree is what? You can see the one that has power. So the power there is 2. So the degree is equal to 2. So that's how to find that. So anytime there is the radical of fraction, you find a way to eliminate that radical of fraction so that everything will now be in polynomial form. You can see this one is in polynomial form. Number 4, dy dx plus sine dy dx is equal to 0. I told you the derivative has to be in polynomial form, and our polynomial form cannot have sine, cannot have any trigonometric identity, cannot have sine, cannot have tan, and so on. So here we can see that the order is what? The order is 1, but the degree cannot be defined because this derivative is not in polynomial form. So it has to be in polynomial form. But if we can find a way to eliminate this sign, then we can go ahead. But for this example, there is no way we can eliminate this sign. So we can now say that degree not defined. So example 5. The cube y dx cubed then raised power 2 over 3 is equal to what? The y dx plus 2. So what is the order? We can quickly determine the order. I told you in order the exponent doesn't concern us. So what concerns us here is how many times was it differentiated. And here you can see that the highest one is 3. So that means the order is equal to 3. Now, to find the degree, we said that the derivative has to be in polynomial form. And polynomial cannot be fraction, so we have to find a way of eliminating this power in fraction form so that everything will now be in polynomial form. So what do? Then you multiply this side, raised power, you cube it, then you do this one too. So we have what? the cube, y the x cube, then this 3 will cancel 3 raised power 2 equals the y the x plus 2 then raised power 3. So we can leave it like this, it's fine, but if you still want to expand, it's okay. But for this class, I'm going to leave it like this. So here we can see that the order is 3, and the one that has the highest power, the highest derivative, its power is what? 2. So it is its power that will determine the degree. So the degree is equal to what? 2. So can you see it is not difficult, but you just have to pay attention to the definition. That is the exponent or power of the highest derivative. You have to determine your order first before you can determine your degree. And in finding the degree, the derivative must be made free of radicals and or fractions, that is has to be in polynomial form. So till I see you again. Thank you. Bye bye.